Hello guys, I'm Jaylor Saladares, and in this video I'll be sharing to you how to solve some sort of application involving extreme value theorem on a closed interval. Ready na ba kayo? Okay, so let's start. Okay, so bago natin umpisahan ang application ng extreme value theorem, kailangan muna natin i-define yung mga different definitions. Ano ba ibig sabihin ng absolute minimum and absolute maximum, and so with the definition of the extreme value theorem on a closed interval. So let me introduce to you with this definition. Definition number 1 says that f of x is said to be the absolute maximum value of a function f if c is in the domain of f and if f of x is greater than or equal to f of x for all values of x in the domain of f. For the second definition, we have f of c is said to be the absolute minimum value of the function f if c is in the domain of f and if f of c is equal to f of x for all the values of x in the domain of f. Okay, let's continue. The third definition, actually this is a theorem. This is the extreme value theorem, says that if a function f is continuous in a closed interval ab, then f has an absolute maximum value and absolute minimum value on a closed interval ab. To illustrate that, in this graph, we can see if this is a function, let's say this curve is a function f, for example, this is function f. And as you can see, in a closed interval AB, from this point A to point B, meron tayong makikita na lowest point, this point is the so-called absolute minimum, and the highest point is the so-called absolute maximum. Remember that we can only apply the extreme value theorem in this particular function if the function is continuous on a closed interval. Closed siya in terms of this interval AB. Pero yan tayo makikita dito, local maximum tawag dito. Bakit? Kasi mataas siya, ngunit mas mababa kaysa doon sa absolute maximum. Kaya ang tawag dyan ay local maximum. In this particular video also, I'll be sharing to you how to solve for the value of the different extrema. Bago kasi tayo pumunta doon sa application, kailangan muna nating i-review kung paano kumuha ng mga extrema, absolute maximum, absolute minimum, and the critical numbers for a particular function. So in this video, there are different steps, step 1, step 2, and step 3. Let's try this function f of x equals 4x squared minus 6x plus 5 on a closed interval 0 and 2. For step 1, first is that we need to find for the critical numbers. Now, how to find the critical numbers? We need to find the first derivative of the function f of x. So this is f of x equals 4x squared minus 6x plus 5. Its first derivative is f prime of x equals 8x minus 6. That's the first derivative. And after getting the first derivative, we let f of x equal 0. So if we try to substitute f of x to 0, ang mangyari po is 8x minus 6 equals 0. And then solving for the value of x, we get 6 over 8 or 3/4 or 0.75. After that, for our step 2, find the value of y or find the y values. Substitute lamang natin yung value ng closed interval 0, 2, and our critical value in our original function. So, anong original function natin? That is f of x equals 4x squared minus 6x plus 5. Substitute natin yung 0, magiging f of 0 equals 4 times 0, 0 squared minus 6 times 0 plus 5 equals 5. Next, f of 2 equals 4 times 2 squared minus 6 times 2 plus 5, and that is equal to 9. Next, our critical value f of 3/4 equals 4 times 3/4 squared minus 6 times 3/4 plus 5, and that is equal to 2.75. After getting all the values of y for our step 3, find the extrema. Now, if you can see, 9 here is the highest value among the 3. So that, therefore, 9 is the absolute maximum. And 2.75 is the lowest value among the 3. So this is therefore our absolute minimum. Alright? So, since alam na natin kung paano kumuha ng values ng mga extrema natin, yung maximum, minimum, now, pupunta na tayo doon sa mismong application ng absolute or extreme value theorem. Okay. So our first example, a cardboard box manufacturer wishes to make an open box from pieces of cardboard 12 inches or 12 inches square by cutting equal squares from the four corners and turning up the sides. Find the length of the side of the square to be cut out in order to obtain a box of the largest possible value. Take note of that. We need to obtain the length of the side of the square, a square to be cut out in order to find for the largest possible volume. So meron tayong illustration number 1, nandito yun, which illustrates the problem. Kung ito yung corner na kailangan natin ikakat, 4 yan, 4 corners, square yan, and that is to be cutted and turned up. Mangyayari, pag ito kinat mo, tas tinurn mo, pupunta siya dito sa illustration number 2. Now, if we let this side to be x, okay, x, and this one is, alam natin na 12 inches yung haba ng cardboard. 12 inches. Tapos, tatanggalin mo yung corner na yan. Pag tinanggal mo yung corner na yan, ang maiiwan ngayon is 12 minus 2x. Bakit 2x? Kasi x inches doon, x inches diyan, mangiiwan is 2x. So, overall, 12 minus 2x. Ang mangyayari, pupunta siya dito. Pag tinurn mo siya pataas, pupunta siya dito. So, 12 minus 2x, tapos dito, 12 minus 2x, tapos yung kanyang height is x inches. Okay? So, let's solve. Yan, okay. So, for our solution, of course, we let x to be equal to the number of inches in the length of the sides of the square to be cut out. And we also let v to be the number in cubic inches in the volume of the box. Okay. The number of inches in the dimensions of the box are known to be the product of the length, the height, and the width. So therefore, going back to our illustration, if this is the length, the height, and this is the width, length is 12 minus 2x, 12 minus 2x for our width, and our height is x. And therefore, we have our working function or equation to be v of x equals x for the height, 12 minus x for the width, 12 minus x for the length. Okay? Now, by inspection, if we let if we let uh, if we let x to be equal to 0 in this function, the whole function will become 0. Palitan mo ng 0 yan, 0, 0. So 0 times 12 times 12 will become 0. And so, if we let x, by inspection lang, if we let x to be equal to, say, 6. Sorry, this is supposed to be 2x. 2x, I'm sorry. This is supposed to be 2x. 2x. Alright. So if we let x to be equal to 6, if this is 6 times 12 minus 2 times 6 is 12, which is this one turns to be 0. This one turns to be 0 also. So the whole function will also be equal to 0. Now, the value of x that we wish to find is in the closed interval 0 and 6. Alright? So because v is a continuous in the closed interval 0, 6, it follows from our extreme value theorem that v has an absolute maximum value on this closed interval. We also know that this absolute maximum value of v must occur either at our critical value or critical values inside this closed interval 0, 6, or at the endpoint of the interval. Endpoint means either it is from 0 or from 6. That's our endpoint. And our critical value is found inside in our closed interval 0 and 6. To find the critical numbers of v, we find for the first derivative of our function f of x. Okay, our function is f of x equals x times 12 minus 2x times 12 minus 2x. So to find for the critical value, we find first for our first derivative. So our first derivative is equal to before we find for the first derivative, let me expand first the function. This is equal to 144 x minus 48x squared plus 4x cubed. And after that, we find for our first derivative. Our first derivative will then be equal to 144 minus 96x plus 12x squared. That's our first derivative. Okay. We know that in finding for the critical value, we need to let our first derivative be equal to 0. So setting v prime of x be equal to 0, we have 144 minus 1, this is 96x plus 12x squared equals 0. Okay, you notice 12, 96, and 144 has a common factor of 12. So kung lalabas mo yung 12, mangyayari 12 times x squared minus 8x plus 12. Dinis-arrange lang po natin yung function. Yung 144 ginawa natin dun sa last. Tapos yung 12x pinunta natin dito sa unahan equals 0. And this function, if we try to solve this further, will give us x equals 6 and x equals 2. So these two, yan na ngayon ang ating critical value. Critical value or critical number. Yan. Now, the critical numbers of v are 2 and 6. both of which are closed in the interval 0, 6. In our interval 0, 6 earlier, 0, 6, you notice that 6 is defined on this interval, 2 is also defined in this interval. So the absolute maximum value of V on 0, 6 must occur either at our critical value or at the endpoint 0 and 6. Now, because V of 0, if we let this x equals to, if we let this V of x to 0, we notice that the value of V is equal to 0. While if we let x to be equal to 6, we notice also that our V is equal to 0. And that's not what we wanted, because we want the largest possible volume. At ang kukunin natin dito is the length of the side of the square to be cut out. So, disregard na natin ngayon ang value na 0 and 6. So, therefore, we can conclude that the absolute maximum value of V on our closed interval 0 and 6 is what? If we try to substitute 6, 2, and 0 in our function, if we try to substitute V of 0 is equal to 0, trying to substitute our values in our original function, V of 6 is equal to 0 also, and V of 2 is equal to 128. So therefore, the absolute maximum value, as we can see, 128 is the maximum or the highest among the three, is then 128. And that occurring at the value of 2. So therefore, what can you say? Therefore, the largest possible volume is 128 is cubic inches, and this is obtained when the length of the side of the square is 2 inches. Okay, and we're done. An island is at point A, 6 miles offshore from the nearest point B on the straight beach. A store is at point C, which is 7 miles down the beach from B. If a man can row at the rate of 4 miles per hour and walk at the rate of 5 miles per hour, where should he land in order to go from the island to the store in the least possible time? So, underline natin yan. Kailangan natin is the least possible time. Now, try to study this illustration. Sabi niya, an island is at point A. So, this is the island. This is point A, which is 6 miles 6 miles offshore from the nearest point B. This A, this is the point B, and the distance is 6 miles. A store is at point C. So this is point C, nandito yung store, which is 7 miles down the beach from point B. This is point B, point C, and the length between from B to C is 7 miles. So the length from this point to this point is 7 miles. If a man can row at the rate of 4 miles per hour and walk at 5 miles per hour, where should he land in order to go from the island to the store at the least possible time? So, saan siya dapat lalapag in order na manggagaling siya dito sa island, papunta siya sa store na yung pinakamabilis para sa kanila, para sa kanya na makakapunta siya sa store. Okay. So let's try this one. So for our solution, of course, we let P be the point on the beach where the man lands. So if a man will land on point B, then therefore, point P, this is the point P. P is located between point B and C. So therefore, the man rose from point A to point P, and then the man walks from P to C. And that is illustrated in this one. A man from point A, row, to point B, then point P, then point P, lalakad siya, papunta siya sa store. Okay. We also let X to be the number of miles and the distance from B to P. That's the distance between, from point B to point P. We let that as X. Also, we let T to be the time it takes the man to make the trip from A to C. So if a man from point A will row from point A, papunta siya sa point C. Gagamit siya ng bangka from point A to point P, and then from point P to point C maglalakad. So, gaano katagal siya magti-trip o gaano katagal siya magti-travel from point A to point C. If that's the idea, then P will be the number of, T will then be the number of hours in time to go from number of hours from point A to point P plus the number of hours from point P to point C. Now, having those idea that a man travels from point A to point P and then from point P to point C, then therefore, since time is obtained by dividing the distance by rate, then therefore T will be the distance from A to P, that is the distance from A to P, divided by the rate, which is the rate of a man travels from point A to point P, is that we have 4 miles per hour. So divide by 4 plus the man it takes to travel from point P to point C. Take note that if a man travels from point P to point C, maglalakad po siya. And the rate of walk is actually 5 miles per hour. So this one is the absolute value of, or the distance from point P to C. Okay? Divide by its rate, which is 5 miles per hour. Now, from our illustration, we see that A to P is actually the length of the hypotenuse of the triangle ABP. AP is the hypotenuse of this triangle ABP. Now, having that idea, therefore, that the length of A to P is actually, how do we get the length of the hypotenuse? That is the square root of the squares of the two sides. This is the hypotenuse. How can we get this? We need to find for the square root of the squares of the two sides. So therefore, this is x squared plus 6 squared is actually 36. We also notice from this illustration the distance from P to C, having the idea that B to C is actually 7 and this is x miles, therefore the distance from P to C is actually 7 minus x. The distance from P to C is equal to 7 minus x. Okay. So from our equation earlier, over 4 plus the distance from P to C over 5 will then be equal to, take note, our distance from A to P is this one, square root of x squared plus 36, that's our AP. So palitan lang natin yun dito. Square root of x squared plus 36 divided by 4 plus RPC. The length of RPC is 7 minus x. So 7 minus x divided by 5. And this now is our working equation in the function of x. Okay? So now, try to imagine, because the distance from B to C is 7 miles, and the distance from P can be any point between B and C. P can be here, can be here, can be here, can be here. We don't know that. Okay? So therefore, having that idea, we are actually we now conclude that we are actually working on a closed interval 0 and 7. 7 is the distance between B to C, and the distance from P to C, without knowing that P anywhere, by knowing that P is anywhere between P and C, then P can be 0. So therefore, 0 and 7 is our closed interval. Now, having this interval, then we therefore wish to find for the value of x, for which t has an absolute minimum value on this closed interval. Because t is continuous on 0, 7, this function is continuous within this closed interval 0, 7. We know that from our extreme value theorem, the absolute minimum and absolute maximum exists within this closed interval. Okay? And before we finally get those extrema, we need to find first for our critical values. And how do we find the critical values? We need to find first for the first derivative of our function. So therefore, our first derivative, doing some sort of working with this function, our first derivative f of x will be equal to x over 4 square root of x squared plus 36 minus 1 over 5. That's our first derivative. Now take note from this one, t of x exists for all values of x. Now, setting t prime of x be equal to 0, and then solving for value of x. Therefore, x over 4 square root of x squared plus 36 minus 1 over 5 equals 0. 1 over 5, transfer it to the other side, will leave us, and doing some sort of calculation will leave us 5x equals 4 times square root of x squared plus 36. Okay? Okay. So 5x equals 4 times square root of x squared plus 36. Solving for the value of x. What do? We have square root, so we need to extract the root by squaring both sides of the equation. So if you can square both sides, this will leave us 25x squared equals 16 times x squared plus 36. Okay? 16 times this one, x squared plus 36, will give us 25x squared equals 16 times x squared plus 16 times 36. Okay? Now, dividing both sides by the common factor of this one, 25, 16, and 16 times 36 will give us, sorry. This one, take note, common value, the same same term. This one will be transferred to the other side, will leave us 9x squared equals 16 times 36. Okay? And then, dividing both sides by 9 will leave us x squared equals 16, 36 divided by 9 is 4. So 4 times 16 is 64. Will give us x equals negative 8 and x equals positive 8. Okay. Now this value, negative 8, is actually the extraneous root of our equation is actually the extraneous root of our equation 4 divided by 4 x divided by 4 square root of x squared plus 36 minus 1/5. And this value, positive 8, is not within the interval 0, 7. If you notice, this positive 8 is not actually within the interval 0 and 7. So what we can now conclude is that therefore there are no critical values. Therefore we can say that there are no critical values. No critical values. Now, next thing to do is that with having the idea that we can actually find for the extrema within the endpoint of the interval 0, 7, or within a critical value, but the problem is that we don't have critical values. So this will leave us, we will be finding or be solving for the values of the extrema within our n.0 and 7. So this time, we do this. We let uh, x to be equal to 0, and we also let x to be equal to 7. So if we have t of 0 from our equation, this will leave us 0 over 0 over sorry, square root of 0 square plus 36 over 4 plus 7 minus 0 over 5. This will give us 29 over 10. And for this one, t of 7 equals square root of 7 square plus 36 over 4 plus 7 minus 7 over 5. This will give us, doing some sort of calculations, will give us square root of 85 over 4. Okay, so this now, 29 over 10 and square root of 85 over 4 are the extremum or the extrema. Okay? So ngayon, the problem is that we are actually getting for the least possible time. So having that idea, we are going to look for the least, meaning we are going to look for the absolute minimum. So ano bang mas malaki ngayon dito? 29 over 10 tapos square root of 85 over 4. Actually, ang mas malaki dito ay 29 over 10. So kung mas malaki ang 29 over 10, i-disregard natin ngayon ang 29 over 10. At ang kukunin natin ay square root of 85 over 4. So therefore, since square root of 85 over 4 is less than 29 over 10, therefore, the absolute minimum value of t on our closed interval 0, 7 is square root of 85 over 4 occurring when x equals 7. When our absolute minimum occurs when x equals 7, take note of that. If this point B is our origin from 0, and this one, the distance from B to C is 7, then what can we conclude? It is better for the man to row from point A directly to the store without doing some walking. Mas magandang didiretso na lang yung man na manggagaling siya dito sa island na point A, pupunta siya sa point C, diretso na gamit ang bangka. So therefore, we can conclude. Therefore, okay, in order for the man to go from the island to the store, in the least possible time, he should row directly there and do no walking. Okay, and we're done. Find the dimensions of the right circular cylinder of the greatest volume, which can be described in the right circular cone with the radius of 5 inches and the height of 12 inches. Illustration number 1. This is the right circular cone. There is a right circular cylinder inside with the height of h and the radius of r. Take note that we are tasked to find the dimension of the right circular cylinder. So therefore, we need to find for the value of this r and the value of this h. Having the idea that the height of the cone is 12 inches and the radius of the cone is 5 inches. Okay. So for our solution, we let r to be the number of inches in the radius of the cylinder. We also let h to be the number of inches in the height of the cylinder, and V for the number of cubic inches in this time in the volume of the cylinder. Okay. Now let's go back to the illustration. Illustration number 1 shows the cylinder inscribed in a cone, while this illustration number 2 shows the plane section through the axis of the cone. Take note of that. Within the axis of the cone, we can generate a plane section, which is a plane figure, which is this one, using the concept of ratio and proportion. We can actually find for the relationship between the radius of this small triangle out here and the radius between the radius of this larger triangle. Pero mamaya natin gagawin yon. Ang una natin gagawin is that let's study the illustration number 1. Our illustration number 1, if we try to let the radius of this cylinder to be equal to 0, if we let that r to be equal to 0, and if we let this h, gagawin mong 0 yung radius niyan, magiging flat yung cylinder, at tapos gagawin mong 12 yung kanyang height, itong cylinder na gagawin mong 12 yung kanyang height, ang mangyari h equals 12. Ang mangyari ngayon, kung mapapansin nyo, magiging flat siya, hindi na tayo makakabuo ng cylinder. So therefore, mangyari dyan, magkakaroon tayo ng degenerate cylinder. And this is actually the axis of the cone. Also, kung gagawin mo namang 5 yung radius ng cylinder na yan, tapos gagawin mong 0 yung kanyang height, if we let this r to be equal to 5 and yung height ay 0, also magkakaroon tayo ng flat, which is not the standard form of a cylinder. Therefore, magkakaroon din tayo ng degenerate cylinder, which is, this is actually the base of the cone. Okay. Having this idea, we can now conclude that we are actually working on a two closed interval. And what is this closed interval? We are working for R, we are working for the closed interval 0 and 5. And in H, we are working on closed interval 0 and 12. Okay. We know for the fact that getting the volume of a cylinder, we have this formula, V equals pi r square times height. Now to express this formula in terms of single variable, we need another equation involving R and H. Now going back to our illustration, using relationship of using ration proportion, and using the relationship between this triangle, yung maliit, and the triangle, the bigger triangle, this one, okay? This side corresponds to this side of the bigger triangle, and this one, the radius, is correspond to this side of the triangle, which is the radius of the cone. Take note that these are the radius of the cylinder. So this is using ratio and proportion. This side corresponds to the bigger side. This R corresponds to this 5 inches. So therefore, we have um, 12 minus H over R equals 12 over 5. Okay, thus, solving for H in terms of R will give us H equals 60 minus 12R over 5. Okay. We have this H, we have the formula. Now substituting the value of H in the formula will give us V equals pi r squared times height. We have H to be equal to 60 minus 12R over 5. So we have, in terms of R, V of R will then be equal to pi times R squared times 60 minus 12R over 5. Okay. And then, let's simplify. V of R will be equal to 60 divided by 5 is 12. And we have this 12 in here. So this is 12 over 5 times pi. Take note that this one is a constant. Multiplied by 60 divided by 5. And then we have this one, 12. So therefore, may 1 dito is 5R. Take note, meron tayong R dito kanina. So R squared minus R times R is R cubed. And this is with R in closed interval 0 and 5. Okay, because this function is continuous in a closed interval 0, 5. It follows from the extreme value theorem states that there is a maximum or absolute maximum value within this closed interval 0 and 5. The value of R and H that give this maximum value of V are the numbers we wish to find. So that in finding for the absolute maximum value, we need to first get the first derivative of this function in terms of R. The first derivative will then be equal to, take note, this is constant. The derivative of constant is a constant or 0 multiplied by this one will give us 12 pi over 5 times 5 times 2, which is 10, or 2 minus 1 raised to 1 minus 3 or 3 minus 1 is equal to 2. Okay? And after that, we let v prime of r be equal to 0. This will give us 12 pi over 5 multiplied by 10r minus 3r squared equals 0, which is equal to, this one's a constant, so this is 10r minus 3r squared equals 0. Okay, you know that there is a common factor r, so we can factor out r. So from 10r minus 3r squared equals 0, factor out r times 10 minus 3r equals 0. And then solving for the value of r will be equal to 0 and r will be equal to 10 over 3. Okay, so these two are the critical values, because v prime of x, which is this function, is actually both close. I mean, this one is close within 0 and 5. This value 0 and 10 over 3 is defined within the this closed interval 0 and 5. And therefore, the absolute maximum value can be within these critical values, or within these critical values, or within the endpoint of the interval 0 and 5. Okay, so therefore, we can say that the absolute maximum value of v on 0,5 must occur at either 0, 10 over 3, or 5. Okay, so now substituting this value 0, 10 over 3, and 5 in our original function, from our function v of r equals this one, 12 pi over 5 times 60 minus 12r. Okay, setting r equals 0, we have setting r equals 0 equals 0. Okay, because if we try to substitute 0 in this r squared, this whole of this will become 0. And if we try to substitute r to be equal to 10 over 3, our resulting value will then be equal to, try to verify this using calculator, we'll have 0, 10 over 3 will have 400 over 9 pi. And if we try to substitute r to be equal to 5, if r to be is equal to 5, then this one will be 60 minus 12 times 5, which is actually 5 times 12 is 60. 60 minus 60 is 0. Then the whole of this will become 0. Therefore, as you can see, this one is the highest. So therefore, this is the absolute maximum value, 400 pi over 9. Alright? So therefore, we can conclude. Therefore, the absolute maximum value of V is 400 over 9 pi. And this occurs when R equals 10 over 3. Okay? Take note that we are tasked to find for the dimension of the cylinder, which is, we are tasked to find for the value of R and the value of H. And we have now the value of R, which is 10 over 3. And then, ang gagawin na lang natin ngayon is kukunin natin yung value ng H. Okay? So, when R is equal to 10 over 3, from this formula, H equals 60 minus R over 5. I mean, from this equation, minus 12R over 5. Then, H is equal to 60 minus 12 times 10 over 3 all over 5. And this will give us H equals 4. Okay? So we have now, therefore, the dimension of the cylinder is R equals 10 over 3 and H equals 4, with the maximum possible volume of 400 over 9 pi. Okay?